Good morning, class. Sorry that I am not here today to teach you all, but don't worry. We'll have a video. Mrs. Hopkins is your sub today, and she will be the master of ceremonies as far as the video is concerned. So please, if it goes too fast, speak up and ask her to pause it. Try to make sure that you're not the problem, that, that everybody's having a hard time keeping up when you ask to pause it, okay? All right, so here's your warm-up for today. So if you could take out a piece of paper and get started on this, we'll give you about 3 or 4 minutes to get these two problems done. While you're getting a piece of paper out, please also take out the scavenger hunt paper that you had from last time and your homework from last time, and we will go through all of those things before we start into notes for the day, okay? So go ahead and pause the video for about 3 minutes. Okay, so we're back. Let's talk about your warm-up really quick to make sure you know what you're doing. Please note that I did ask you to solve over a specific interval. I was looking for specific answers instead of just in general, so that's kind of something to know about. Note. All right, so this problem on number 1 is already set up to be equal to 0, and you can use the zero product property. And over here, I'm going to get the cosine of x ends up equaling plus or minus 1/2. And this one, I would get the tangent of x equals plus or minus the square root of 3. When I'm doing these, then I'm going to get two sets of answers. I'm looking for where does the cosine of x equal a positive 1/2, and where does the cosine of x equal negative 1/2. Please remember that cosine are x values. So in my unit circle, I'm looking for x values equal to positive 1/2. That happens at pi over 3 and 5 pi over 3. Okay, so this one gives me x equals pi over 3 and 5 pi over 3. For where does cosine equal negative 1/2? Well, that's an x value, so there's 0, there's negative 1, so halfway. If I go up, I'm at 2 pi over 3. If I go down, I'm at 4 pi over 3. So this is x equals 2 pi over 3 and 4 pi over 3. All right, great. So now I'm with tangent, and tangent's the other thing I got to deal with. Okay, so I'm really looking for where does tangent of x equal root 3? Where does tangent of x equal negative root 3? Now remember, tangent is sine over cosine, or x values over y values. So I want to have a square root of 3 left, which means I'm actually in the same place I was before. At pi over 3 and 4 pi over 3, I get the positive case. So whoops, this one down here would be x equals pi over 3 and 5 pi over 3. Where do I get the negative root 3? Well, that's at 2 pi over 3 and 5 pi over 3. Uh-oh, hang on, this should be 4 pi over 3. My bad. How about 4 pi over 3? Okay, so the negative ones came from x equals 2 pi over 3 and 5 pi over 3. Please note that these are duplicate answers, that you had the same for both the cosine junk and for the tangent junk. We don't need to have repeated answers, so we'll just circle the one set and move on with life. Okay. Over here, you've got a multi-angle. That means we're going to end up tripling the number of answers that we have. Okay. So if I went through and solved this, I would get the secant of 3x equals plus or minus 2. Okay. So secant of 3x is going to equal positive 2, and secant of 3x equals negative 2. All right. Well, then the question is, where does secant equal 2? Well, secant goes with cosine, so that's the same question as where does cosine equal 1/2? Well, 3x is our argument. So I would say, what are the angles where you had a cosine of 1/2? Well, pi over 3, and 3x equals 5 pi over 3. Where does secant of 3x equal negative 2? Well, that would be cosine equaling negative 1/2, which is right back here, which again is that 2 pi over 3 and that 4 pi over 3. Now, I'm writing them this way because it's not a singular angle like problem number 1 was. It's a multi-angle. And so, in fact, I would tell you that it's probably a good idea to just go ahead and say plus 2 pi n on all of these. And the reason I'm doing that is because eventually I need to solve for x, and I have to divide by 3 everywhere. So divide by 3, divide by 3. Everywhere is getting divided by 3. And I have to go ahead and do the plus 2 pi n and add those things up because I'm going to have rather large angles. Okay, I'm going to make myself a chart here, and I end up with, let's see, pi over 9 plus 2 pi n over 3. That's going to be one set. All right, and then I'm going to have 5 pi over 9 plus 2 pi n over 3. And then I'm going to have 2 pi over 9 plus 2 pi n over 3. And, oops, that was a weird one. And 4 pi over 9 plus 2 pi n over 3. And I'm making this, goodness, come on, work. I'm making this lovely chart because I am going to have to substitute in for n. Okay, so if n equals 0, what are my answers? Well, just pi over n, 5 pi over 9, 2 pi over 9, and 4 pi over 9. Now, if I plug in n equals 1, what happens here is that I actually have to start adding 2 pi over 3's. If I multiply top and bottom by 3, that means I'm really adding 6 pi n over 9. Literally, guys, I want to add 6 to each of the answers every time I add or go to the next n equals 1. So if I add 6 over here, 1 pi over 9 becomes 7 pi over 9. This becomes 11 pi over 9. Add 6, I get 8 pi over 9. Add 6, I get 10 pi over 9. Let's go to n equals 2. How far do I need to go, right? I'm supposed to go to 2 pi. Well, 2 pi is equal to 18 pi over 9. And the biggest I've got right now is 11, so I do need to keep going. So add 6 again, this is 13 pi over 9. Add 6, 17 pi over 9. Ooh, that's really close to 18 pi over 9. Add 6, I get 14 pi over 9. Add 6, I get 16 pi over 9. And I love it. My computer just died. Let's hope that I'll still be recording here. Okay, let's pretend like this is still working. Great, let's check. I just had some kind of an issue here. Am I still recording? No, I'm not. That's just freaking great. What is going on? Oh, maybe I still am. Okay, just kidding. All right. Whoo! That was a close one. All right, so if I would keep going and add another 6 pi over 9, everything gets too big. So these 6 answers, haha, just kidding. 12 answers are the ones that we're looking for problem number 2. All right, switching gears. Let's go back to the scavenger hunt. I'm recording this before I know how far you all have gotten. So I am leaving up the scavenger hunt posters around the classroom for today. And if we still need time, go ahead and grab a dry erase board that you used last time to write upon and your scavenger hunt sheet. And I will write down someplace, Mrs. Hopkins, where or how long I think the kids will need to complete the scavenger hunt. So find your scavenger hunt sheets from last time, go ahead and try to find the problem you left off on, and let's go ahead and finish those right now. And again, please look at my notes, Mrs. Hopkins, for how long I think they need. Okay, go ahead and pause the video. All right, children. So let's just check your answers quickly. Here's what I would say. Please find in your notes this particular problem. Okay, sine of x plus the square root of 2 equals negative sine of x. Okay, so that could be any problem. Anybody could have started anywhere. So find that problem. And what I would like you to do is check your answers. Okay, the answers to this are 5 pi over 4 and 7 pi over 4, which means this is your next problem. Okay, the answer to this particular problem is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. If for some reason your answers aren't matching mine, that's okay. Just try to jump in and find the next equation that we're dealing with. So see if you can find tangent squared of 2x equals 3. And the answers to tangent squared 2x equals 3 should be all 8 of these answers. Pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. I'm sure you have them in a different order than they have them. And that's totally fine, okay? But you do have 8 answers for that. All right, the next problem you should have is 4 cosine of x equals 1 plus 2 cosine of x. And the answer to this problem are just these two answers, pi over 3 and 5 pi over 3. Okay? Then you should be left with the next problem, which is sine squared x plus sine of x equals 0. The answers to that, well, there's 3 of them, 0 pi and 3 pi over 2. Okay? And then please note that this is your next problem. 3 cosecant x minus 2 equals 0. The answers to that should be this. Okay? And then the next problem you have is cosine cubed x equals cosine of x. The answers to cosine cubed x, there are 4 of them. They're all of your quadrantal angles. Okay. And then we're dealing with 2 sine of x, and I'm just making weird shapes, I don't know why, minus cosecant of x equals 1, and the answers to that are 3 of them. There you go. 2 sine squared x plus 2, or equals 2 plus cosine x. Those answers should be right here. Pi over 2, 3 pi over 2, 2 pi over 3, 4 pi over 3. Okay. The answers to 2 sine squared x minus 3x minus 1 should be pi over 6, 5 pi over 6, and pi over 2. The answers to tangent squared x plus tangent of x equals 0 are these 4 answers. Okay. The next problem you're supposed to have is 2 sine squared 2x equals 1. And the answers to that, woo, baby, there are 8 of those, and they're all over 8. Okay. 4 cosine squared x equals 2. Have 4 answers, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. 4 sine squared x divided by 3 equals 1. You only get 1 answer. The other answers that you probably thought of were too big. Okay. Ooh, look at this one. This is a doozy. Okay, so this one you definitely have to factor by grouping. So that big, long, honkin' equation have answers, those 3 answers. And I kind of feel like we're back to the beginning, but I could be totally wrong. Okay, so sine squared x equals 1 minus cosine x should be these 3 answers. I'm wrong. This one goes on forever, doesn't it? Okay, we should almost be there. And so the answers here to sine x plus the square root of 2 equals negative sine of x. Hey, we're done. Just kidding. We're totally done. Yay, us. Okay. Let's look at homework. I'm not going to worry about collecting the scavenger hunt just yet, so we'll deal with that later. Homework questions. I think that we will just go ahead and have you all plan on asking those questions next class. So part of your homework tonight ought to be for you to circle the problems that you know you struggled with so that we can make sure that we can help you with those next class, okay? Tonight's homework is weird looking. And in fact, you don't have to do all of it tonight. This is actually your homework for today and your next class. So you do have some time to get that done. Okay, so on page 381, you're going to do 9 to 13 odd. That's pretty normal looking. Okay, but what about this right here? Okay, please add in the or equals to on your homework because that would make more sense. Here's what you're going to do. When n equals 6, then you plug into this equation. So this would be 3 times 6 minus 1, which is 17. So you're going to do problem 17. Okay. Then when n equals 7, you're going to do 3 times 7 minus 1. Well, that equals 20. Okay. You're going to calculate those all the way up through 16. Here's the deal. I wanted you to do every third problem, but since they weren't multiples of 3, it was super awkward. So I went with this kind of way to work about it. So basically, you want to do every third one. So 23, 26, 29, 32, and so on until you get to 47. Okay? Then this next piece right here are multiples of 3 when n equals 7 to 24. So basically these are saying let's do 51 to 72 mults of 3. That one I could have written out a little bit nicer. Sorry. But anyway, that's how you're going to do your homework tonight. That's what that means in your answer or your what is that called? Your schedule. Okay? All right. So let's shift gears. We are going to be starting all sorts of formulas. And so we're going to start with, I think I skipped a slide. Oh yeah. We're going to start in section 5-4, which are sum and difference formulas today. We will take notes today. We will continue those notes next time. So I don't know when the bell will ring for this set of notes. So just be mindful that we'll get as far as we can. Next class, we'll finish them up, and we're taking a quiz over sections 5-1 to 5-3. So please be aware of that. And then the following class after that, we'll practice sum and difference formulas. So we'll be on sum and difference formulas for a couple of days here. The very first part is the intimidating part, and the rest of it kind of just falls into place very easily. But since you guys are honors kids, unfortunately, then that means I'm going to show you the theory behind why all these formulas work. And that kind of makes things complicated. All right. So hopefully you've put away your warm-up, you can put away your scavenger hunt, you can put away your homework, and you've got out a piece of paper for sum and difference formula notes. Okay? Our first goal today is to be able to figure out what is the cosine of pi over 12. This is one of the very first things I had on your district growth measure, just so you are aware, okay? All right, so this is our goal. We'll come back to it and try to answer that question. I need you all to try and draw 2 of these lovely little pictures in your notes. Basically, you could think of it as an X and Y axis with kind of a unit circle. And I would go ahead and draw 2 of them because the diagrams get really confusing really fast, okay? If you would go and look up what is the formula for the cosine of u minus v, and you were looking for how do you get that formula, they would have these circles, okay? And they would be superimposed on one another. And I just want you to see that, well, one, I blocked some things out, but you end up trying to see a couple of different things and it gets really confusing very quickly. So I don't want you to do that. Oh, that's not good. I just ungrouped things. I want you to kind of understand here that these circles are supposed to be the exact same size. And I think that'll help a little bit. Okay, so in the very first circle, ooh, Mrs. Hopkins, there should be some pens out. They're different colors. If the kids want to come up and grab them so that they can kind of have their picture match my picture, that would be fantastic. Okay? But what I want you to see over here is that, maybe I'll go to highlighting here. Let's see, highlighter, let's go to green. I want this angle to be angle U, okay? And then I want this angle right here to be angle V. Please note that we're trying to find how much is U minus V. Well, U minus V would actually be this angle. Crazy, huh? All right, so that's in our very first circle. That's kind of what's going on there. And then we're going to assume we're kind of on the unit circle for our proof. Obviously, you could be on any size circle, but it just needs to be the same in both drawings that you have, okay? So noting that, I'm also going to go down here and draw this other one. So this is the same. This is meant to be the same size. I still want this U minus V in red, you can kind of see it in red, is the exact same size as the one we drew up top. Okay, that purple one is supposed to be the same as this red one down here. All I've done is I have reorientated it so that I am over here in red land and that my angle is really this angle, okay? So that this is also U minus V, okay? So I want those two things to be identical. All right, so we're going to go to dual page, full screen, move it over, and I'm going to go ahead and I think get rid of this picture. Maybe, maybe not. Let's try it again. Let's get rid of this, and let's get rid of this. I think that'll make our lives a lot easier. Oh, go away. How do I get this to go away? All right, so here's our proof. Again, we're talking about the formula for the cosine of U minus V. Please keep in mind when you're looking at the unit circle here, cosine of an angle is equal to the y, no, what is cosine equal to? Come on, Herman. Cosine is always equal to the x value on a unit circle, right? We're on the unit circle here, so just kind of keep that in mind that the x values are all really just cosine here. Okay, here's what we're going to say. The measure of angle BOC, that's your purple angle, BOC over here, this purple angle is equal to the measure of angle AOD. AOD is over here. This is the red angle. Okay, so we've just reorientated them so that the red angle is on that positive x-axis. Okay, so if that's true, and since both things are on the unit circle, here's what I want you to understand. I want you to understand that this distance here then between B and C is the same as the distance between A and D, because we're supposed to be on the same circle. And so the circles are the same size, and that makes life wonderful. So AD is congruent to BC, which means the distance between A and D is equal to the distance between B and C, because congruent segments have equal distances. Okay, well, how do I find the distance of AD? Well, distance, I have a point and I have a point. Let's go with the distance formula, right? That would make sense. What's the distance formula here? Well, you subtract your x values. So x sub 3 minus 1 squared added to y sub 3 minus 0 squared. That's how long AD is. Well, how long is BC? BC in that top area. Well, that's going to be the square root of let's do x2 minus x1 squared added to y2 minus y1 quantity squared. Okay. So I have more room to write. I'm going to get rid of the split screen here. Okay. My whole point here is that these two segments, because we're on a unit circle and because we said the angles are congruent, those two segments are congruent. Okay. That's the premise that we're going with here. Let's go to single page and let's go to full screen and let's advance this. Okay. Woo! See how big that writes when I got split screen? Okay. So here's the deal. AD is equal to BC. And we just came up with two equations for those things. Ready? So AD is the square root of x cubed minus 1 squared plus y cubed minus 0 squared. And that's supposed to equal BC, which is x2 minus x1 squared plus y2 minus y1 squared. All right, here we go. I need to solve for x3. Okay, what does that mean? Basically, if I'm trying to find the cosine of u minus v, cosine is x values. This would be our value. What is x sub 3? That's what we're trying to find. That's what we're going to solve for. Okay? So here I go. How do you solve for x sub 3? Where is x sub 3? There it is. Okay, so let's get rid of the squares, or the square roots, I'm sorry. So I've got x cubed minus 1 squared plus, well, y cubed squared. Let's just get rid of that. And I've got x2 minus x1 squared plus y2 minus y1 squared. Here we go. Let's simplify things. Okay, so this first set of perfect squares would be x cubed squared minus 2x cubed plus 1 plus y cubed squared equals, okay, here we go, x sub 2 squared minus 2x sub 1 x sub 2 plus x sub 1 squared. I'm just foiling things out, people. Plus y sub 2 squared minus 2y sub 1 y sub 2 plus y sub 1 squared. Okay. We are on the unit circle, right? We're on the unit circle on our pictures. Here's what I would like to tell you. Unit circle, we usually have this Pythagorean identity. Sine squared of an angle plus cosine squared of an angle equals 1. Well, if you're on the unit circle, y squared plus x squared should equal 1. We're going to change our subscripts on this, and it could be x sub 1 or x sub 2 or x sub 3. Point being, check it out. That's the same thing right there as cosine squared of x plus sine squared of x. So that equals 1. So I've got 1 minus 2x sub 3 plus 1 equals, now check this out. Oh my goodness. X sub 2 squared and a y sub 2 squared. That's equal to 1. X sub 1 squared and a y sub 1 squared. That's equal to 1. How come? Well, again, really, x squared plus y squared is the same thing as sine squared of x plus cosine of squared of x. It's just a Pythagorean identity. Okay, so what was left? 2x sub 1, x sub 2, minus 2y sub 1, y sub 2. Okay, check this out. This is 2 minus 2x sub 3 equals 2 minus 2x sub 1, x sub 2 minus 2y sub 1, y sub 2. I'm collecting terms here. I could subtract 2 from both sides. So I get negative 2x cubed equals negative 2x sub 1, x sub 2 minus 2y sub 1, y sub 2. Do you notice that everything has a negative 2 in it? Let's divide it out. X sub 3 equals x sub 1, x sub 2 plus y sub 1, y sub 2. We have just successfully solved for x sub 3. What does that mean? This is the cosine of u minus v. That's what x sub 3 represented. This is equal to the cosine of v times the cosine of u plus the sine of v sine of u. I probably should have addressed that a little bit better in the beginning of this. Okay. This is the the difference formula for cosine. Okay. So if I look at all of this, here's what I need you to understand. Scroll down. This formula that we've got down here, the cosine of v. If I go all the way over here, here's angle v. This is this blue angle, right? The cosine, cosine is x value. So the cosine of v is really x sub 1. That's why I substituted that in. There's x sub 1. I substituted that in. Over here, this is my u angle, this big one over here. So the cosine of u is equal to x sub 2. That's what that's kind of dealing with over there. And that's where I got all of those values. All right. Okay, let's go back to a single page, full screen, moving on. Okay, so let's go back to our goal. The question is, how do you find the cosine of pi over 12? Well, the cosine of pi over 12 is equal to the cosine of two things that could be subtracted together. And it just so happens that pi over 3 minus pi over 4 equals pi over 12. Check it out. Pi over 3 minus pi over 4 is equal to pi over 12. Okay, so if I multiply top and bottom here by 4 and top and bottom here by 3, so I have like denominators, I get 4 pi over 12 minus 3 pi over 12. Yes, that's pi over 12. Very good. Okay, so you have a u, you have a v. So what was our formula? Our formula was the cosine of v cosine of u plus sine v sine u is what we'd kind of want to deal with. Okay, so here we go. What's the cosine of pi over 4 times the cosine of pi over 3 plus the sine of pi over 4 times the sine of pi over 3. That's all we're doing. We're just kind of substituting in. What is the cosine of pi over 4? Well, that's root 2 over 2. What's the cosine of pi over 3? Hey, that's 1/2. What's the sine of pi over 4? Root 2 over 2. What's the sine of pi over 3? That's root 3 over 2. So what's my answer over here? This is the square root of 2 over 4 plus the square root of 6 over 4. A lot of times we'll combine these to be the square root of 2 plus the square root of 6 over 4. Okay. We have 5 more problems to derive, but they go a lot faster. Okay? Just so you are kind of aware. Okay, let's try another one. What's the formula for the sum of angles for cosine? Okay? And in this problem, we're going to switch what was v to negative v. In other words, we used to have the cosine of u minus v. Maybe I'll put this as like v prime. Okay. I'm going to rewrite this as the cosine of u minus negative v. Okay, just to kind of rewrite that. And do you see how that really is the cosine of u plus v? Okay. Cosine of u minus v is typically, what did we say it was? Oh my goodness. We said this was the cosine of v cosine of u plus sine of v sine of u. We're going to change, we're going to use the same formula, but we're going to change slightly what we're plugging in for. Okay, so this is the cosine of negative v cosine of u plus sine of negative v sine of u. And then we're going to think back to odd versus even. Okay? Think back to odd versus even. This simplifies to cosine of u plus v. cosine is an even function. So a negative on the inside means you still get the same thing. I'll bring down cosine of u. Sine of negative v brings a negative out front. So this becomes sine of v, sine of u. And this is the sum formula for cosine angles. Okay. All right. We have 2 of our 6 angles, or 2 of our 6 problems. Okay. We'll continue on. Our next thing that we want to find goal-wise is how do you deal with sine of adding and subtracting different angles. So the sine of 75 degrees is where we will start. That's goal number 2. And so to do that, we actually have to find the sine of a sum of angles for sine of u plus v. Okay? All right, we're going to start with what we know. We know that the cosine of u minus v is the cosine of v times the cosine of u plus the sine of v times the sine of u. Okay. We're going to let, in this formula here, instead of having u, we're going to write pi minus u instead. Okay, so here we go. Substitute it in. The cosine of pi over 2 minus u minus v is kind of what we're dealing with here. Okay? So this should end up being the cosine of v times the cosine of pi over 2 minus u plus the sine of pi over 2 minus u. I should have written that the other direction. Let's keep it all the way you like it. The sine of v, the sine of pi over 2 minus u. Okay. I'm going to do some magic on this side, this left side. The cosine here is really pi over 2 minus, I'm factoring out a negative sign, u plus v. Okay. And now I want you to go back and think about cofunctions. This is the cosine of v. What is the cosine of pi over 2 minus u? This is a cofunction answer. You're talking about a 90-degree difference. Well, this is the sine of u. Okay? Plus, you've got the sine of v. And again, this is a cosine problem, or a cofunction problem. So sine of 90 minus u is really just the cosine of u. All right? Again, over here on the left-hand side, when you have 90 degrees minus an angle, you get the cofunction, which is just the sine of that angle. That's from last chapter, guys, in the beginning of this chapter. And the way they write this one, this is the sum of angles for sine. I don't know why they put the sine first. So sine u cosine v plus cosine u sine v. I should say they don't put the sine first for no reason. They just put angle u first for whatever reason on that one. Okay? So if we go back to the goal is what's the sine of 75? Okay, so I'm going to think the sine of 75 as the sum of 2 angles that we know. What are 2 really nice angles that I could add together and get 75? What would those angles be? Well, how about 30 and 45? Right? So now we have a sum of angles for sine, and so I can say this is the sine of 30 times the cosine of 45 plus the sine of 45, and these should all be degrees. You should write degrees as well, times the cosine of 30 degrees. Okay? Sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Plus sine of 45 is root 2 over 2, and the cosine of 30 is root 3 over 2. So when I simplify this, I'm getting root 2 over 4 plus square root of 6 over 4, which is root 2 plus root 6 over 4, and poof, there's your answer. Okay. All right. If we get through this next one, that'd be great. We'll see how this goes. Okay, so the sine of, well, difference of angles for sine is what we're going to do next. So here I go. I'm going to base this off of the sine of u plus v, right? So the sine of u plus v is the sine of u cosine of v plus sine of v cosine of u. Please know, guys, I am not going to expect you to have these formulas memorized. In fact, after we get through some these kind of examples, these problems, you'll be getting an orange sheet to hang on to that has all of your formulas on it, okay? Okay, so I'm going to let, for our purposes, I'm going to switch out v with negative v. Okay, so this is the sine of u plus negative v. So everywhere I saw a v, I'm going to change it to negative v. Sine of u stays put. This becomes cosine of negative v. This becomes sine of negative v, and the cosine of u stays put. Now, think about odd versus even. The left side changes into sine of u minus v. Cosine over here of negative v. Cosine's an even function, so it doesn't change. Sine u cosine v stays put. However, the sine of negative v, sine's odd, so the sign will change. That negative sign comes out front, and we end up with sine v cosine u. All right. There's your formula for difference of angles for sine. Okay. There are actually 6 of them. We have not gotten through tangent. Tangent's not too difficult. Again, I don't know how long class will go here, but I am going to go ahead and start the proof for tangent just because, again, I don't know when the bell is going to ring, but we can get through that. And then if we don't get through it, we'll finish it up next class. No big deal. Okay, so let's look at tangent and talk about how do you find that answer in that problem. Okay, so here I go. What's the formula for tangent of u plus tangent of v? I'm going to say this is tangent of u plus v. And tangent is simply just the sine of that angle divided by the cosine of that angle, right? That's a u. Maybe I should give a little hook at the end of my u's to help out. Okay, so what was the sine of the sum of angles? This is the sine of u cosine of v plus sine of v cosine of u all over cosine u cosine v minus sine u sine v. Wonderful. Okay, what's our overall goal? Yeah, check it out. We're supposed to change everything to in terms of tangents and cotangents, or tangents and tangents. Okay, look, there's your symbols, plus minus. This is supposed to say plus minus on the top, but it switches on the bottom. Crazy, huh? Check this out, though. Remember, tangent is sine over cosine. Sines stay the same. Cosines, sines will switch. So does it make sense that on tangent, it's sine, the sine stays the same on the top, divided by cosine, the sine's going to switch on the bottom. Okay, fantastic. How in the world am I going to change everything into tangents? More importantly, this thing right here has to become a 1. How could I make that become a 1? Well, I could multiply it by 1 over cosine of u cosine of v, right? And whatever you do to the top, because this is kind of like a verifying problem, I have to do to the bottom. All right, so that's what's going on there. Let's simplify. This is going to be the mother of all division problems. This has to get distributed to both things on the top. So I've got sine u cosine v over, let's see, I should probably make that a u there. That'd be a little bit easier. Cosine u cosine v plus sine v cosine u over cosine v cosine u. There's the big division problem. Distributed over here. I get cosine u cosine v over cosine u cosine v minus sine u sine v over cosine u cosine v. I hope you can kind of see what happens. First of all, those cosine v's divide out, those cosine u's divide out. These two things divide out. Okay, so what am I left with? Sine u over cosine u is really just the tangent of u, plus sine v over cosine v is really just the tangent of v, over. Again, these two things divide out. I'm left with a 1, minus sine u cosine u is the tangent of u, times sine v cosine v is the tangent of v. So this is the tangent of u plus v, and we could do the same exact thing for finding the tangent of u minus v. All right, we are going to stop here. Please note that you do have a quiz next class, and your homework that's assigned for today is really not due until 2 classes from now. Okay? Thanks so much. Sorry it was so long.